The motion of the stars. The electromagnetic dome in which the stars are imprinted, as we explained in the plasma imprint chapter, rotate around us centered on the pole star. But at what angular speed is it rotating? The Sun, from what we saw in Book 3 in detail in the chapter where we analyze its movement, makes a spiral movement. The angular velocity of rotation that concerns us here has to do with a component of its circular motion. Within 24 hours, it makes a complete rotation. The Moon has a smaller angular velocity as it lags behind the Sun by about 52 minutes each day, making one complete circle in 24 hours and 52 minutes, thus defining the lunar day, where 29 lunar days make a lunar month. That is why every day the Moon lags behind the Sun by approximately 12.4 degrees in terms of their rotation around magnetic north. The Moon is tied to the Sun, and in which constellation it is depends on its position in relation to the Sun, which fact also defines its phases. To return to the dome of stars and constellations, observing their movement, it is apparently similar to the Moon's and the Sun's one. The stars come from the east and live towards to the west, tracing a circular path centered on Polaris that is up from the magnetic north with a certain angular velocity similar to that of the Moon or the Sun. The Sun passes, or best aligns, within a year of all the constellations in the dates from the solar calendar as described by the zodiac circle. Next year, the Sun will be on the same date, exactly the same point in the zodiac cycle of the constellations, and the one-year loop is completed. If we consider the relative speed of the Sun in relation with this of the electromagnetic dome where the stars are captured, we can develop the following rationale. In 365.25 solar days, the electromagnetic dome with the stars lags behind the Sun by 360 degrees. In one solar day, we find that it lags behind the Sun by 0.98 degrees. If we consider that for 24 hours equals 1440 minutes correspond to 360 degrees, then we find that 0.98 degrees corresponds to 3.94 minutes. Summarizing, we calculate the constant angular velocity of rotation with center the Polaris and the magnetic north of all the above phenomena in relation to the fixed and motionless Earth. Sun angular speed. The Sun rotates at a constant angular velocity of 360 degrees per day equals 15 degrees per hour, or else the Sun makes a full circle in 24 hours, as we know. Moon angular speed. The Moon rotates 360 minus 12.4 equals 347 degrees per day equals 14.46 degrees per hour, or else the Moon makes a full circle in 24 hours and 52 minutes. Stars angular speed. The dome of stars and constellations rotates 360 minus 0.98 equals 359.0144 degrees per day equals 14.959 degrees per hour, or else the stars and the constellations make a full circle in 24 hours and 3.94 minutes. Because of these different speeds, the Sun passes through all the constellations within a year, while the Moon, due to its individual motion in relation with the Sun, passes through them in a lunar month. Also because of this fact, we see different stars on winter nights compared to summer nights. It is because the Sun, which carries the plasma of daylight with it, is in an antidiametrical constellation in the winter in relation with the summer, so at night, that we see the rest of the sky that is not day, we see the other side of the electromagnetic dome that the stars and constellations present. Angular speed of Sun. Here we see the so-called sun trail seeing a piece of the Sun's course here specifically as it rises. This path is spiral as we saw in Book 3, examining the analemma. The circular component of the spiral motion is observed here. The angular speed of the Sun is equal to the duration of one day, 24 hours. In other words, the Sun makes one complete rotation around magnetic north every 24 hours, no matter what latitude it is at. So we're talking about partially different instantaneous speeds, but a constant angular speed of rotation. Angular speed of Sun, A Sun equals 360 degrees per day. We measure time with reference to this constant motion of the Sun, thus determining the days of the year and the dates according to the latitude and the direction of the component of the harmonic oscillation of the total spiral motion made by the Sun. Angular speed of Moon. Here we have a moon trail at a moonrise seeing a bit of its spiraling motion. The Moon has a constant angular velocity of rotation lower than that of the Sun, so every day it lags behind the Sun by 12.4 degrees or about 52 minutes. And here we are talking about different individual measures and vectors of speed, but the angular speed of rotation remains constant. Angular speed of Moon. A Moon equals 360 minus 12.4 equals 347.6 degrees per day. By delaying the Moon each day in relation to the Sun, it lags behind of the constellations and the phases are created. Stars' angular speed. The stars and the electromagnetic ethereal dome also revolve at a constant angular velocity around the pole star. And here also we have different measures and vectors of the individual velocities of the different stars according to how near they are to the pole star, which remains stationary since it is the center of rotation and is always in a fixed point. On the other hand, stars further away from the pole star run at a higher linear velocity. However, the angular velocity of rotation remains constant. Angular velocity of stars and constellations. A stars equals 360 minus 0.98 equals 359.0144 degrees per day. Due to this speed, which is slightly less than that of the Sun, we have the Sun aligning with a different constellation every month, while in exactly 1 year, the Sun returns and aligns with a constellation that was aligned a year ago. The Moon has to do with the Sun, and its phases are inextricably linked with the distance in constellations from the Sun, changing all 12 constellations within a lunar month in about 29 days. Southern stars. The very southern stars appear to diverge from the north rather than converge like those further north. The stars are the imprints of Earth's energy points in the etheric space on the ceiling of our electromagnetic field. This is because below is what creates all of this cosmic electromagnetic frequency field, that the material part being the lowest one. This cosmic electromagnetic energy source, also called the Black Sun, moves below and also rotates in a maximum and minimum radius, each time having a different angle of incidence from bottom to top. The surface of the Earth is larger than the radius of rotation of the black sun, so we have some areas of the Earth inside this circle and some outside. However, energy points exist all over the Earth. Thus, the imprints of energy points within the radius of the black sun appear to converge to the north, while the imprints of those outside the radius diverge due to dynamics and geometry. Night visible sky. We see that the Sun, the Moon and the stars are moving with different angular velocity, and their relative velocities make us observe all these alternations that define three moving layers. In the night sky we necessarily see the rest of the electromagnetic dome that is not day. The stars in the night sky are changing position for a little every night, until in a year, at the same time, they will be exactly as it was a year ago. We will see that the sky looks like every first of every month at 12 o'clock in the midnight exactly, for months in a row. There is a slight movement of the stars each month due to the different and slightly greater angular velocity of the Sun relative to the stars. So every day, for the same time, in the same place, the visible sky is a little different, something we will observe in the following video. We observe that the relative angular velocity of the star canopy relative to the angular velocity of the Sun's rotation creates repeated alignment conditions every year at the same time. An observed slight deviation created the leap years where they repeat every 4 years, having 1 day more, 366 days, and thus we would say that the total deviation of 4 years is equalized by the addition of this day. Planets' motion in the constellation circle. The so-called planets, when not visible at night, are on the side of the electromagnetic dome where the Sun is and creates the day. In this video, we see the analemma of these etheric imprints, the planets during 14 solar calendar months in relation to the Sun. We achieve this by taking a picture every day at the same time. We notice that Mercury and Venus always follow the Sun in the constellations and always appear close. Mars, Jupiter and Saturn appear in all the constellations, tracing a geocentric course of complex spiral motion. Moon. The Moon, as we have seen, makes a complete revolution in the constellations within a lunar month, within approximately 29 solar days. Mercury. Mercury revolves around the Sun following it through the constellations with an oscillation around it in a small radius. It appears only in the constellation in which the Sun is located and in its neighbors. It performs a complex spiral motion and does not revolve around the constellations but around the Sun. There are periods when Mercury is retrograde, that is, every day it goes against the constellations. In one solar year, it rotates 4.14 times around the Sun while making a complete rotation in 88 days. It is the one satellite of the Sun phenomenon and has phases like the Moon. Venus. Venus revolves around the Sun, following it in constellations with one oscillation around it over a large radius. There are periods when Venus is retrograde, that is, every day goes against the constellations. In a solar year, it rotates 1.536 times around the Sun while making a complete revolution in 224.7 days. It is the other satellite of the Sun and has phases like the Moon. Mars. Mars follows the course of the constellations and behaves geocentrically, making a complex spiral movement. Its rotation speed is less than that of the constellations. In one solar year, it makes 0.5319 revolutions of the constellations and thus makes one full revolution of the constellations in 696.98 solar days. Its two satellites move in opposite directions. Jupiter. Jupiter moves almost along with the constellations in a geocentric course in a complex spiral motion. Its path through the constellations repeats every 4,334 days, since its rotation speed is almost equal to that of the constellations. Thus, in one solar year, Jupiter makes 0.0349 revolutions in the constellations. Its four satellites move in the same direction. Saturn. Saturn follows the course of the constellations, making a complex spiral motion while behaving geocentrically. Its speed is even closer to that of the constellations, so that it makes a complete circle through the constellations in 10,822 solar days. Consequently, in one solar year, it makes 0.0349 rotations through the constellations.